In this video, we are going to go over integration, how to find the antiderivatives of certain functions. Now, if we remember how to get the derivatives of certain function, according to the power rule, x raised to the constant of n, a variable raised to a constant, is equals to n times x raised to the power of n minus 1. Now, the power rule when dealing with antiderivatives is like the opposite of getting the derivative. So let's say, so instead of subtracting your exponent by 1, we add 1. And then you divide the answer. So it's going to be x raised to the constant of raised to the power of n plus 1 over n plus 1. And then you're going to add the constant of integration. So plus c. Now that's basically the power rule for integration. Now let's work on some examples. So let's say we're gonna get the derivative of x squared. Now according to the power rule, you're going to multiply the exponent to the constant, so it's gonna be 2x, and then you're going to subtract your exponent by 1. So it's going to be 2x, 1 or 2x, just 2x. Now if we get the antiderivatives of 2x, so let's say 2x. So this is going to be 2x. There's always a constant 1 here, so going to get 1 plus 1 over 1 plus 1. So this will become 2x squared over 2. And then you simplify. We can get rid of 2 here, so this is gonna be 2 squared plus c. Another example is, let's say we're gonna get the antiderivative of x cubed. So it's gonna be, first we integral of x cubed plus 1 over 3 plus 1. So this is gonna be x4 over 4, then add a constant of integration. Another example, dx. So this is gonna be x 10 plus 1 over 10 plus 1 plus c. It's gonna be x over 11 over 11 plus c. That's your answer. Another example is x over 8. First, you put the 8 outside, so this is going to be the same as 1 over 8, uh, whatever. So there's always 1 on x, so this is going to be 8x times x1, and then we multiply 1 over 8, so it's going to become another example is, well, how about we get this function, so 4x squared. Now how do we get the antiderivatives of this function? So we just exactly do the same. First, you put 4 outside, so this is going to be 4x squared dx. And then we get the antiderivative of x squared. So x squared plus 1 over 2 plus 1. This is going to be x cubed over 3 times 4 equals 4x cubed over 3 plus c. Always remember to add the constant of integration. Now, there are techniques in finding the integrals of certain functions, but in this video, we're going to focus on these 5: integration by substitution, integration by parts, integration using trigonometric identities, integration of some particular functions, and integration by partial fraction.
Integration by substitution. Integration by substitution, also called U-substitution or the reverse chain rule, is a method to find an integral, but only when it can be set up in a spatial way. U-substitution essentially reverses the chain rule for derivatives. In other words, it helps us integrate composite functions. Usually, the method of integration by substitution is extremely useful when we make a substitution for a function whose derivative is also present in the integrand. The function simplifies, and then the basic formulas of integration can be used to integrate the function. In calculus, integration by substitution, also known as U-substitution, reverse chain rule, or change of variables, is a method for evaluating integrals and antiderivatives.
In this video, I'm going to show you how to integrate using U-substitution. So we're going to focus on definite integrals. How can we find the antiderivative of 4x times x squared plus 5 raised to the third power? So what we need to do, we need to find two things. We need to identify the u variables and du. Now, whatever you select u to be, du is to be the derivative. If we select u to be 4x, the derivative will be 4, and that's not going to get rid of x squared plus 5. Now, if we make u equal to x squared plus 5, du is going to be 2x, which can cancel the x, and 4x, and that's what we want to do. So, let's set u equal to x squared plus 5. Du is going to be 2 times but times dx. So now, I'm going to solve for dx in this equation. So I divide both sides by 2x is equal to du divided by 2x. Now, what we need to do is replace this with u and replace the dx with du over 2x, and it will work out. So we have 4x and the u raised to the third power, and then du divided by 2x. So here we can cancel x. 4x divided by 2x is 2. So it's 2 times the antiderivative of u to the third. Using the power rule is going to be 2 times u to the fourth over 4 plus c. Now 2 over 4 is 1 half, so it's 1 half u to the fourth plus c. The last thing we need to do is replace u with what it equals, and it's x squared plus 5. And this is the final answer.
Integration by parts. So basically, integration by part is one of the techniques in solving integral. So we have a formula that u dv is equal to uv minus integral of b du. So given an integral, we're gonna assign if who is u and dv in such a way that the resulting integrals will be easy. So let's have some examples. So for the first one, evaluate integral of x e raised x to x dx. So usually integration by parts are commonly used if we have product of two functions. So in this case, we have product of x and the e raised to x. So now we're gonna assign u here. So we're gonna let integral of any u that we want. So let's say we're gonna let u be the x, okay? And then the next step is we're gonna differentiate both sides. So getting the derivative of u equals the x of both sides, we have du is equal to the x, right? And the rest is obviously for dv, is this expression e raised to x dx. So we're gonna solve v by integrating both sides. So the integral of dv is v equal integral of x e raised to x, so equal to e raised to x. So we're not gonna put this in. So that's my hint for you all. Ilalet nyo yung dv in such a way that it will easy to integrate, like the e raised to x dx. Therefore, integral x series to x dx now is like this is our new given. So let's evaluate this. We can now put plus c. Therefore, this is the final answer.
In this technique, we're going to focus on trigonometric integrals. To begin, we might want to write down some notes just to review some formulas that will be useful when integrating trigonometric expressions. First is sine squared plus cosine squared is equal to 1. Next is 1 plus tangent squared is equal to secant squared. This is a good review of some trigonometric formulas that you've been exposed to in the past. The next one you need to be familiar with is 1 plus cotangent squared is equals to cosecant squared. Next, we have the double angle formulas. Sine 2x is equal to 2 sine x cosine x. Wait, let me fix that first. And then cosine 2x. There's three forms that you can convert this into. You can convert this into cosine squared minus sine squared you could set it equal to 1 minus 2 sine squared right? 1 minus 2 sine squared or 2 cosine squared minus 1. Now the first problem that we're going to work on is this one. Let's find the antiderivative of cosine to the third x. Wait, let me fix that first. Cosine to the third. So what do you think we need to do here? What we could do is we can write cosine cubed as cosine squared times cosine. And what we want to do is we want to change cosine squared into 1 minus sine squared. Keep in mind sine squared plus cosine squared is equal to 1. Solving for cosine, we can move sine squared to the other side. If we do that, we'll get that cosine squared is 1 minus sine squared. So we're going to replace cosine squared with 1 minus sine squared Now, the reason why we want to put it in this form is so that we can do u substitution. If we make u equal to sine x, du is going to be cosine x and dx. So that's why we have to keep at least one cosine on the outside so that we can use it to change it into du. So this part here is du, and we're going to replace sine with u. So this becomes the integral of 1 minus u squared du, the antiderivative of 1 is going to be u. The antiderivative of u is u to the third over 3 plus c. Now our last step is to replace u with sine. So our final answer is going to be sine x minus 1 over 3 sine to the third plus c. So that's the antiderivative of cosine cubed.
In this class, we will prove that integral of 1 divided by a square minus x squared dx equal to 1 by 2a into log mod a plus x divided by a minus x plus c integral of 1 divided by a squared minus x squared dx integral of 1 divided by, you observe that it looks like a square minus b squared. What is the formula for a square minus b squared? A plus b into a minus b. So a squared minus x squared can be written as a plus x into a minus x. Okay, now we can do this integration in two methods. One is integration by using partial function. Another one is by using a trick. So I am doing this problem by using a trick. What is the trick? Look here. That equal to, you observe the answer is the answer 1 divided by 2a is there. We know that 2a is constant. So what I will write here, 1 divided by 2a integral of, in the numerator also I will write 2 divided by a plus x into a minus x dx. You observe here, if 2 will get cancelled again, you will get the same step. The equal to 1 by 2 into integral of here. I'm going to follow the trick. What is the trick? You write these two things. What are there in the denominator? One is a plus x, another one is a minus x. You write these two things. You check to add these two numbers or subtract these two numbers such that you will get to try to understand. I'm taking these two terms in the denominator now. What I will do, either way I do, such I will get to, suppose I will check with addition. Here when I writing plus symbol, so here plus x minus x will get cancelled. A plus a is what to a, so here 2 I can be written as 2a, can be written as a plus a minus x. The trick, divided by a plus x into a minus x dx, that equal to 1 by 2 into integral of you observe this expression can be written like this. Suppose something is like this, plus b divided by c, you can write it as a plus c plus b. By c here, how we can write this expression? We can write this expression as a plus x whole divided by a plus x into a minus x, plus a minus x divided by a plus x into a minus x dx. I hope you understand this expression. Right, written as a plus x divided by denominator plus a minus x divided by denominator part. You can see here that it's plus 6a plus x will get cancelled here, and minus x will get cancelled, but is remaining 1 by 2 into integral of here 1 divided by a minus x is remaining plus here 1 divided by a plus x is remaining. What I'll do here, I'll integrate these two terms separately. Integral of 1 divided by a minus x into dx plus integral of 1 divided by a plus x into dx. I hope you understand. That equal to 1 by 2 a into, now we need to integrate this expression, integral of 1 divided by a minus x dx. You observe here, we learned this formula in previous classes. Integral of dash of x by f of x dx is log mod f of x plus c. Numerator is the derivative of denominator. If numerator is the derivative of denominator, then we will write its answer log mod f of x plus c. You observe here, what is the derivative of minus x? Look here, of minus x derivative of a constant 0 minus derivative of x with respect of x is 1, so is minus 1. Derivative of a minus x is 1. Here observe derivative of a minus x is minus 1, and the numerator of only plus 1 is there. So for our convenience, I will write minus of minus 1 divided by a minus x dx. You will see here minus minus will become plus again. You'll get same step what is there above, plus I will integrate this in the next step, integral of 1 divided by a plus x dx. I hope you understand that equal to 1 by 2a into 2a into, look here what is the real now you observe here what is the derivative of ax. Derivative of a minus x is minus 1. It's derivative of their numerator. That means this integral of minus 1 derivative by a minus x dx come into the form of numerator, that derivative of denominator. Then what is the answer? Log mod f of x means denominator, that we will write here log mod minus x plus you see here what is the derivative of plus 6 z derivative of plus x, derivative of constant 0 plus derivative of x with respect to x 10 plus 1 is what? Plus derivative of plus x is 1. That means numerator is the derivative of denominator. That means it comes under this form, so we can write it answer directly. What is the log mod f of x plus c? What you get here, log mod is plus x plus c. Okay, that equal to 1 by 2a into c log m. Log in from try to understand log m. Log in, what is the formula? Log m minus log in, formula is log m by in. So here what is it will be, this will be log mod plus x divided by a minus x plus c. So finally I'll conclude what we proved. We proved that integral of 1 divided by a square minus x square dx equal to 1 by 2 into a log mod a plus x divided by a minus x plus c. From now onwards, we can use this as a formula.